Hello everyone, I am Arush Mallik of class 8. I study in Pristine Public School, Bangalore. Today I have made my science exhibition project, Tesla Coil. So, this Tesla coil was made by Nikola Tesla in the early 1800s. Earlier, there used to be various magnetic coils. The major disadvantage of these magnetic coils was that they had a very low connectivity range, and Nikola Tesla figured out this problem by inventing this Tesla coil in the early 1800s. And this Tesla coil's one advantage is that it has a very high connectivity range. So, this the materials required to build this project are 28 AWG copper wire, which we can see over here, and the CL100 transistor, and this metal foil ball, and also the 2.2k ohm resistor. So there are two main components to understand this project. The two components include the transformer and the resonance circuits. So first, transformer. This is a step up transformer, which means there will be less turns in the primary winding than in the secondary winding. So the secondary winding will have more turns so that it can give a high voltage output, and the primary winding has less turns so that it can take low voltage input. Now, talking about the resonance circuits, these resonance circuits are like a very important to understand this Tesla coil. So for this resonance circuits, we need an inductor and a capacitor. Basically, this is a circuit that allows the current to flow without much impedance or resistance. And this circuit has a very has two main benefits, which are as follows. Number one, how if they cannot transfer energy indefinitely, they can transfer it to some period of time, although they will be losing energy in each cycle. And these have their own frequency at which they will oscillate. That can be calculated by the formula F is equal to 1 by 2 pi square root of LC. So, last but not least, how this coil works. So basically, we need an AC current source just like this, and then after that the current flows through the wires into this transformer. This transformer will take in the low voltage current and transfer it into a high voltage current, and then this new current will flow into the resonance circuits. Now these electrons will find a way to move, and there's the transistor that comes into the play. We have a CL100 transistor just right here. So this transistor's main work is to switch the charges or voltage pulses, to be accurate. The main job is to switch the voltage pulses into the primary winding. Now in the primary winding, again it takes a low voltage input and transfer it into a high voltage output in the secondary winding. Now, so this is how a Tesla coil actually works, and we can see that electricity is transmitting wirelessly, and this is independent of all angles. And now we can also talk about the applications of Tesla coil. This is used in education and entertainment purposes, like education purposes for learning about wireless electricity, high frequency electricity, and it is also used in detecting vacuum test leak detectors. So these Tesla coils are scientists use high vacuum projects, and sometimes there are small pinholes in these kinds of projects. So this Tesla coil is used to detect those pinholes. And there are also so many benefits of using these Tesla coils. One of them is all the charges are distributed evenly in each turn, and also they are independent of all angles of wireless electricity transmission, like here. So that is all about my project. Thank you.